Hello everyone, Reza here with another Unreal Engine tutorial. In this step-by-step video, we're going to explore on how to guide your fluid system using a custom spline path. It's a great technique to art direct the behavior of your fluid inside Niagara VFX system. You can guide it along a tunnel or spin it around your character to make magical spell and so much more. As usual, I have packed a lot into one tutorial, so let's get started. Here I am inside Unreal Engine. I've got a simple scene with just a simple backdrop, one of the ready to go starter pack material. I've assigned that to this backdrop, nothing too special. I removed all of these indirect lights in my scene, atmospheric fog or skylight, so on and so forth. I might actually go ahead and delete the player start as well, and I'm ready to go. For the hierarchy, there's not much in there. I've got a material folder, props folder. This backdrop is in props folder and VFX folder, ready to go to create my Niagara. All right, let's start. The first thing I need to do, and let's go over the plan, is to find a way to guide our fluid simulation. Now, there is a very simple way to guide our fluid simulation using particle systems. And there is even an easier technique to guide the particle system through or along a path. So why don't we create a path, then attach our particle system into the path. Once that's done, we attach our fluid system into the particle system. So when we drive the particle system, the fluid tags along. So that's the whole plan. Let's start with the first chapter, and that is how to create a simple blueprint spline. To create a blueprint spline, all you need to do is to right click, go to blueprint class, and in here we want to pick actor. Now, blueprint spline component is just a path for you to define and use positional data. The good thing about blueprint spline is you can use that as an actor and place it in your level and translate it around. And that's why we want to use actor. I'm going to call that BP for blueprint underscore path, because that is going to be our path. I'm going to dock that right next to my level, and we are ready to go. First things first, we need to add a component, and that component is actually spline. That's why we're using blueprint, so we can create an actor and place it into our scene. I'm just going to create the spline, call that fluid path, and you can see as soon as I do that, I'll be getting a point to select. I actually have 2 points to select, and I have my spline. This is the tangent. This is the other tangent that belongs to this point right here. If I select the other point, I've got again 2 tangents that I can select in order to change the interpolation or the behavior of my spline. Now, I can edit this spline right here, but remember the whole idea was to have an actor and drop it into a scene. So now I can quite easily bring this one here. You can see now I have my blueprint path ready to go. If I press F, I can even go ahead and rotate it. Now what I want to do, I would like to have at least an actor, something in the middle, and wrap this path around the actor, just to make the whole behavior look slightly more interesting as opposed to just a straight line. To do that, I can easily use a simple shape. So I'm going to go to shape. I'm going to go to cylinder. I can reposition that ever so slightly, maybe make it slightly taller, like so. While we at it, why don't we just apply a simple material? I can just go into material right here and just apply one of these ready to go materials. Let's put a metal surface in there. Oh, that's a bit too damaged. Yeah, maybe something like that. And yeah, that looks great. Also, with this BP path, I have a tendency to centralize the position of that, so it just falls right at the center. That's better. I can select this, move it down ever so slightly to have my path ready to go. All right, let's go ahead and just shape this path. We did talk about spline, blueprint spline in our how to use camera rigs inside Unreal Engine. In case you haven't watched that, definitely watch that. It's a really fun tutorial, shows you how to create camera rigs, basically as the name suggests. And the way that you work with this is actually very, very simple. You select a point and you can just individually select a point, move it forward. And if you wish to extend it, you just hold down Alt and you branch out. At any point of time, you select and you can select individual handles and just change the function of each tangent, like so. And you can look at it from different angles and just give it direction. So what I'm going to do, I'm just going to go ahead and speed up the video and wrap this spline around this cylinder, so we have something to work with. There's nothing technical about it. As I said, you press Alt, basically hold down Alt on your keyboard, and you extend your path, and you're pretty much ready to go. All right, let's say that's more than enough. Of course, your scenario can be potentially quite different, but just for the sake of demonstration, I thought I would just spend a little bit of time and make it slightly more complex, so it's not just a straight line. Now it's time to go ahead and create our Niagara system. I'm going to go into VFX folder, right click and create a Niagara system. I can actually use one of the presets and alter it ever so slightly to get the starting point, the result that I want. Any of them, to be honest, will do, since for the particle side of it, we don't really require a super complex scenario. You can even start from an empty emitter and build up the nodes. I'm just going to use a fountain to save a little bit of time. I'm going to go finish and call that NS particles. I'm going to double click on it. First things first, I am going to rename that. I'm going to call that path particle. So we know that this one is in charge of following the path, and it is a particle setup. The background is in the way, so I might as well go in there and switch the environment, turn it off, and bring everything down ever so slightly so we can see the particles properly. Some of these nodes are obviously redundant. For example, we really don't need velocity, we really don't need gravity, we just need a bunch of particles. And that's why I said that you can even start with simple sprite, with sprite burst instantaneous, just a simple spawn rate, simple initialized particle. We've got a shape location, which is a sphere, nothing too special. You can change that to any type of shape that you want. This solver force is not really doing anything at the moment. We've got drag to contain the particles, but having that is also not super necessary. So as you can see, this is a fairly simple setup. I'm going to stop and rewind since we really don't need to see anything at this point. Now it's time to create a scratch pad module, and this is a type of module we've never practiced in the past. This is the first time in our Niagara system tutorials that we are going to use it, and it's a module, it's a one-off behavior type of module that you only want to use it in a particular Niagara system. But it's a great module to somehow tame and control the positional behavior of our particle system. Now we tend to put that into our particle spawn because we want our particle spawn to actually get that behavior as soon as they get generated. So I'm just going to type in new scratch, and you can see new scratch pad module. And it actually takes me to scratch module, which is still in Niagara system, but it gives me a different window to play around with. Let's actually explore this window a little bit before we get ahead of ourselves. So in here, you can see I can bring in modules, all the modules that I can bring inside this Niagara system. I can bring it in here and make use of it, you know, multiply, add, append, so on and so forth. We've got map get, and that is going to allow you to get multiple values from your parameter map. And similarly, this allows you to set multiple values into your parameter map. And of course, you will output the result, and this will show up in your Niagara system inside this particle spawn that we have. So you can see our scratch module at the moment is empty, and we are editing it in this window. So any changes we make, any output that we create is going to show up in here, and then we can use that to control the behavior of our particle. Let's name our module something meaningful so we don't basically get confused. Just single left click on it, and I'm just going to call that scratch m underscore path, just to remind myself that this belongs to the particle path emitter. Of course, in here you can add a parameter. I'm just going to click on this plus and call spline. So we have a spline to work with. I'm just going to call this S for spline underscore path because it all evolves around the path that we're trying to create. Now our spline needs a position. So if I type in sample position, I have different sample spline position at my disposal. The one that I'm going to use is sample spline position by unit distance WS. Now we have a node to define the position of our path. This U is going to move the particle along this path. Now what you put here defines how this spline basically operates and how it caters for the particle animation. You can just go in here, go with emitter age, and connect that in one here. But the issue with that is the whole particle system is going to move as a chunk along the path across the timeline. So as the timeline moves, the whole chunk of particles move from point A to point B, and there is no trail, which is something that we don't want. So what I can do is hold down M, left click to bring the multiply. And I'm not really sure why it looks like this, but it is the good old multiply that we all know and love. So we connect that one here. And of course now pipe A goes to age and pipe B goes to the speed of our particles. Now this one is not a float and this value is float. So what I can do is convert numeric to a float and just drag and drop that here and then call that speed. So pipe B speed, pipe A age, this is multiply, that goes into U, which defines how the particles will flow along this spline. Now for this little guy, if I just extend these guys here, we want to connect the position to the position of the particles. So if I type in position, we have particle position, because we, at the end of the day, we want to make sure that anything that we do is along the path, but the position of the particles is something that we are targeting. So simply connect this to this and we go apply. And now if I go in here, you can see we have a scratch path that we produced, user parameter, use lot, and speed, which is the variable that we produce here. Now I really would like to make use of user parameter, and I used user parameter in almost all of my Niagara fluid sims simply because they're very, very powerful. So let's bring that to use. I'm just going to type in read from new user parameter. So you click on this arrow, read from new user parameter, and now this guy is in fact a user parameter. Now let's drag and drop our emitter. I'm going to zero out its position. So it's right at the center. You can see our particle is in here and there is no movement in the particle system simply because of the two reasons. If I go in here, you can see the speed is the default value is set to 0. Probably we set it to any value. We don't really know what value works for us. Let's start with, let's say 0.75, just a random number. And the second reason is when we dropped in our particle, we really didn't assign this scratch path blueprint to it. So if I go in here under user parameter, we have a source and expand path. That source needs to be defined, which is our BP path. There we have it. So as soon as you attach your path into the source of your user parameter, everything now should work beautifully, like so. Now, of course, the look of the particle system is a bit off, so we can just go in here and fix that really quick. And again, these cosmetic changes is something that you may want to have and spend more time on if you just want to have a path and have the particle system follow the path with no fluids. Then you can spend ample amount of time fixing and tweaking. But we know for a fact that at the end of the day, we are going to turn this off and we let this particle emitter to drive our fluid simulation. So we are not going to spend too much time on it. First things first, I really think that this speed also can be a user parameter. So I'm just going to type in read from user parameter. And again, we've talked about this in the past. This is going to extract this from this window and drops it in here in our Niagara system. So we have really good control over the speed and over the things that we can do. So you can see now it's set to 0.75. I can set it to 1, I can set it to 2, I can set it to 3. I really don't need to go into our Niagara system to fix things. I extracted the value, I promoted the value into the main user interface. So that's really convenient. Now let's get into the look of our particle. So now I'm going to have a look at initials particle, because that's where I can fine tune so many things here. First things first, uniform sprite size particle. Maybe I start with 10, maximum to 20. I'm going to set the mask mode to unset. We really don't want to change that at all. For the color, I may actually go with the light blue and a value of 2. And for lifetime, maybe I want this to linger a little bit, so maybe 2 and to 1, give it a really good gap, a good variety. In spawn, this is way too low. I feel like what I'm getting is not enough, so I may actually crank up this to a good amount. Let's have a look. I'm going to go to Niagara particle and activate. Yeah, that actually looks a lot better. Something like that. Probably the lifespan is a bit too much, so maybe 5 to 1. Let's give that a try. Yeah, that's actually a lot better. We need to control the scale, because one thing I noticed is they don't get smaller and die. They actually are the same size and die, which is kind of not ideal. So in particle sprite, this is something that we again talked about in our introduction to Niagara. So if I go sprite scale, sprite size, I can now control the size. So right now it at birth they're 0, and gradually but surely they get complete, and that's probably not something that I want. So let's see what we have. I can actually use this where they are actually full size, and as they go through the timeline they get smaller and smaller and die. And the interpolation is very smooth on this, so that can definitely work. Yes. So if I go in here and auto activate, yeah, that definitely works. Another cool thing that I can add, I think, is a type of noise, because right now it's really neat, clean, straight. So maybe curl noise is something that I can add. The frequency, I can make the frequency just a tad smaller. And for the noise, let's crank it up to a very high value and give it a little bit of animation. So it kind of moves. Yeah, that's a lot better. So you can see how quickly and easily we're managing to make some progress. So let's see that. That's really cool. I really like the movement. Yeah, let's leave it at that. I mean, you can just play around with this forever and add different forces, change the behavior a little bit, add a little bit of velocity, a little bit of chaos. But again, at the end of the day, this is going to drive our fluid system. So let's call it a day on this one. Let's go to the next chapter where the real fun starts, and we are going to create our fluid simulation and attach it to this particle system. All right, let's create our fluid sim, something that I have an entire video on that, so I'm not going to talk about all of those attributes again. I'm going to enable Niagara Fluids. If you wish to put that into your level sequencer, then you enable cache as well. And of course I need to restart. All right, I'm good to go. That allows me to open my Niagara system. I'm just going to stop the timeline. That allows me to right click, go add emitter, and now because I enabled those plugins, I can go to parent emitter and bring in grid 3D gas master emitter. Now by default, it does its own thing and completely ignores the particle. Before I get ahead of myself, I'm just going to name that path underscore fluid. Excellent. Now this needs to simulate with GPU in order to interact with this GPU based fluid sim. Just remember to change that. So GPU compute and bounds to fix, and now these two should be able to interact. Two changes we need to make, one in here, and again I've gone through that in another video, so definitely check that out. I'm going to go through it a little bit faster. So I'm just going to type in set, and that brings in set fluid source attribute. That's what I need from the particle emitter side, and that gives me a good repository and good set of values to deal with, to specify how much density I need, how much temperature I need, so on and so forth. So I'm just going to tone them down because by default they're way too big. Now in the path fluid, I need to make sure that it recognizes the particle as the driver, and I can collapse that. If I go to source, you can see it emits from a sphere, and that's totally not what I want. I can turn it off and I can say, you know what, I have an emitter, why don't you follow the emitter instead? It says, well, that's the name, that's the default name of the emitter. We say nope, the default name of the emitter is path, and it's not path fluid, it's path particle. That's what we want you to follow. With these two changes, we successfully linked the two. So now this fluid can recognize this emitter particle as its path. And the funny thing is, this path now recognizes the blueprint spline that we made as its path. So you can see how we daisy chain these things and gradually but surely get the result that we want. Now in simulation, obviously, what we usually see is just a simple rectangle, and that's not going to work for us. So let's just quickly change these bounds. I know that my Y is pretty lengthy, so I'm just going to make that one 1000 and this one 2000 and Z 1000. For max resolution, I'm going to bump it up to something like 400 to increase the resolution. There is no collision here, but again, as usual, I have a tendency to increase this value. I noticed that this value gives you a really good solve for the resolution max axis, which calculates number of voxels in the longest axis, in this case in Y axis. Now buoyancy, how quickly things are buoyant, we don't really know, so let's leave those as is. And definitely I would like to bring some fun. So temperature, I am going to bring in temperature. I'm just going to ever so slightly move this aside so we kind of get to read what's going on. Now we have dissipation rate, and we have dissipation rate for density and dissipation rate for temperature, and I'm still under simulation. Before I get to the level, I know that for a fact that I need to enable use streaks because my particle is actually moving. So I need to use streaks, need to give it a high value, and I also need to, if I go to simulation, compensate for action movements. So when we move our fluid, it actually reacts to it and it moves, and this is something that can be quite useful. I'm going to increase my dissipation rate to something like 2. And let's not make too many changes in one go, because I really need to see how it looks before I make further changes. So let's save and go in here, and voila, you can see how beautifully now we attached fluid system into our particle system. This looks really cool. I mean, you can tell that the gravity is way too high, and if you're going for a fire look, then that can be your starting point and you can start tweaking things. But chances are you want to get a more of a sci-fi look, let's say spell looking type of magic lightning type of look. In that case, you have to go and tweak things. Now I noticed that the fluid rises really quickly, so maybe minus 98 instead of 980 would be a good value. Let's go and check. Yeah, as you can see, it's not going to evaporate and rises so quickly. Although I must say that was a bit too low. Maybe 110 would be a good starting point. And I'm going to give that just random values in there too, so it just doesn't move up. It kind of goes all around the scene. Now let's go into source and see what other attributes we have available. We really don't need to play around with much. You can play around with density scale or temperature scale. As a matter of fact, I may tone down the temperature scale ever so slightly. I will go to force, and that's where I can add turbulence, something that I do use a lot. Can reduce the frequency to something like 0.2, and vorticity, which is a small scale of turbulence, I'm going to set that to 3. You have so many useful controls in here, and I can spend hours talking about it. And because I really don't have a type or an end goal or a reference, I'm just trying to use the opportunity and explain what can be a fun project to have and how you can really take your the look of your fluid to the next level. So I may actually reduce this 0.1 to maybe 0.075, because I noticed the temperature is still very much saturated and bright. Let's save and take another look. Yes, that's definitely working better for us. Now I noticed that the smoke lingers a lot, and we all know that if that is the case, it's because of the dissipation for density. So I am going to increase dissipation for density, which was set to 0.3. It's a very small value, while we have temperature dissipation set to 2. So that can have a slightly better balance. Now that's around the time that you can start having fun with this and really turn this into whatever you want to turn it to, using the attributes that you have. Let's say I don't want this fire look. Let's say I want to get a more of a sci-fi magical look instead. So if I'm doing this with fire, why can't I turn this into a, let's say, a green fume, a toxic fume, as opposed to a fire look? So again, I'm going to go into render. This is the color of the smoke. The black body is color of my temperature. I'm just going to change that to a curve. And I have the temperature color curve to deal with. You can always have a look at it in the curve editor and have a look at your RGB values, or you can reposition these guys. I can turn off the snapping so I can move things around quicker and much easier. And you can now go ahead and turn that into, let's say, a blue color. Based on that, you can go in there and change the color of your smoke to a slightly bluish color, or maybe greenish, because it's kind of green, not really that blue. Now if I go in there you can see that my Niagara system, if I go and find auto activate, is now blue. It's following the path. I can just disable the path, so, or hide the path, not disable, for lack of a better word, just to be able to see exactly what it's looking and take it from there. There are so many things that you can do. For example, I can go to force, calculate wind, enable it, and let's say we want to have a really good amount of wind in the y-axis. Well, like 20, and switch back to my level. You can see now the wind takes place, and we have this force field sort of acting and changing the behavior of the smoke. Now, that's pretty much it. I can go in there and tweak so many things in here. I can add or increase rather a little bit of velocity in here. I can go and change the dissipation of my temperature even more, and make the smoke or density linger a little bit, right? So all those changes you can definitely make to your advantage. I can enable or increase rather buoyancy of my temperature and get a slightly different look while we have wind, while we have vorticity and turbulence. Now I'm going to go back, and that's a slightly different look. I'm just going to go turn down the intensity to maybe 1 lux, so the particle system can be seen. And also I'm going to go into Niagara system and turn off draw bounds, so we don't see that bounding box in here. And now things can be seen a lot better. And that is it, my friends. Now you can use this technique to your advantage and basically can start connecting your particle into a custom path, and then from that point plug that into your fluid system and take it from there. I hope you found this video useful and use these techniques that we discuss in this tutorial in your project. As always, thank you very much for your support. You can find me on Patreon, Instagram, Reddit, and X. Until the next video, see you guys later.